So sorry. At the end of the last video, I was a little baffled by why my numbers weren't coming out right, and like a bonehead, I was plugging in my x for the r in the formula, 4/3 pi r cubed, and I was plugging in the radical 25 minus x squared for the r. Well, that doesn't work. I mean, with the regular sphere, the r is 5, and so when you, as you can see, 4/3 pi times 5 cubed is the same answer that we got when we integrated from -5 to 5 of pi times the radius, but changes when you integrate from -5 to 5. You get the same answer. So I feel better now. I hope you do too. All is well. And let's go ahead and go to example 2. We've got a I think you could probably do this on your own if you have been following along, so I encourage you to try that. But I'm going to go ahead and get started. So to find the volume of the solid, we have a two-dimensional shape bordered by the curve y equals the square root of x, y equals 0, x equals 4. So, and we're going to take this region right here, and we're going to rotate this region around the x-axis. Okay, so let's see, I've been drawing my rectangles in red, so let me just keep doing that. So here's our first rectangle. Let's see, following the graphic organizer, draw a vertical line from f of x down to the x-axis, and then make a rectangle and reflect the graph across the x-axis. And so the graph of this y equals radical x kind of comes out here like this. Okay, and then now we know how far to draw our rectangle. Find a beginning, A. So the A here would be 0, and our B here would be 4. So we have our endpoints of our interval, and if we add up, we could find the area of this region by adding up an infinite number of rectangle areas by integrating from A to B, from 0 to 4. The area of this rectangle would be length times width. Radical x is the length, and width is dx. But we're going to rotate this region around the x-axis. So let's do this. Let's rotate this region around the x-axis, and it goes all the way around. Okay, all the way around. And I like to shade that part of it right there, the part that comes out towards us. So again, this would look similar to the nose of, let's say, an airplane or something like that, rotating around, and the radius of this disk, okay, radius of the disk is just the function f of x, equal to radical x. And so the volume, let's put that over here, the volume is equal to, we're going to integrate, we're going to add up an infinite number of disk volumes. So we're going to add up an infinite number of disk volumes from 0 to 4, and I like to draw one disk down here. I'm going to try to do that in orange from now on. One disk. Sometimes it's easier for people to see. This disk is radical x is the radius, the dx is the height, and so the volume of one disk is pi times the radius squared multiplied by the height. So the area of the face, or area of the base, multiplied by the height gives us the volume of the disk, and therefore we're just going to plug that in. So the volume of one disk would be pi times radical x squared dx, which is from 0 to 4, there we go, from 0 to 4 times, the integrand then would be pi x, and we have dx. So you could do this by hand. I'm going to go ahead and just show you what the answer would be on the calculator. I'm going to take the time to, don't want to take the time to do that, but what you should do is plug in the, just evaluate the definite integral of pi x from, with respect to x from 0 to 4, and you can see that we get 25.133. Okay, so 25.133 doesn't have any units, so just leave it like that. And if you have the calculator, that fancy ones, then that's how you write it. Okay, and there you go. So there's example 2. That was a 5-minute example. I think I'm going to stop now. I'm going to do the next one on the next video, because the next one's a little bit trickier because we're going to integrate with respect to y, so that might take a little longer.